Hello friends, continuing with the topic of electric flux, today we take up its definition. Last time we have learnt about electric lines of force and their characteristics, and today we take up electric flux. What is its definition? Number of electric lines of force cutting the surface perpendicular to it is defined as electric flux. I repeat, number of electric lines of force cutting the surface perpendicular to it is defined as electric flux. Look at the diagram. This is a rectangular surface S. These are electric lines of force, and this is direction of electric field, and this is the direction of area vector which is perpendicular to the surface. Now how many number of electric lines of force are cutting this surface perpendicular to it will give us electric flux. And now mathematical definition of electric flux. The dot product of electric field vector and area vector is defined as electric flux. I repeat, the dot product of electric field vector and area vector is defined as electric flux, mathematically expressed as phi E is equal to E dot S, where phi E is electric flux, S is plane surface, this S is plane surface immersed in a uniform electric field E. The direction of area vector S is always perpendicular to the surface directed outward. You remember it. It is going to help you in understanding the electric flux and doing its numericals. So always you remember that the direction of area vector S is always perpendicular to the surface directed outward. So phi E is equal to E dot S is the electric flux. Let us mark it as equation 1. Now equation 1 can be expressed as phi E is equal to mod E mod S cos theta. Let us mark it as equation 2, where theta is the angle between E vector and S vector, where theta is the angle between electric field vector and area vector. Now SI unit of electric flux. Newton per coulomb meter square. Newton per coulomb is the unit of electric field and meter square is the unit of area. So SI unit of electric flux would be Newton per coulomb meter square. And type of quantity. It is a scalar quantity. What type of quantity electric flux is? It is a scalar quantity. Now let us take up discussion. Consider equation 2, phi E equal to ES cos theta. When theta is equal to 0, E is parallel to S and phi E is equal to E into S. Flux linked with the surface S is maximum and is positive. The electric lines of force emerge out of the surface. I repeat, when theta is 0, electric field vector is parallel to area vector, then phi E is equal to mod E into mod S. Flux linked with the surface S is maximum and is positive. The electric lines of force emerge out of the surface. So you remember all these conclusions drawn when theta is 0. Now second point, when theta is pi by 2, then E would be perpendicular to surface S, then phi E is equal to 0. Flux linked with the surface S is minimum 0. The electric lines of force lie in the surface itself. We mark this point also. The electric lines of force lie in the surface itself. When theta is pi by 2, the electric field vector is perpendicular to S vector, then phi E is 0. flux linked with the surface is minimum equal to 0 because cos 90 would be 0. The electric lines of force lie in the surface itself. Okay. The third case, when theta is pi, E is anti-parallel to S. Electric field vector would be opposite to area vector. Then phi E would be equal to minus mod E mod S. Flux linked with surface S is maximum but negative. The electric lines of force enter the surface. Okay, you mark these points for all the three different cases, and that will help you to understand numerical problems. Now, alternative definition of electric flux. Surface integral of electric field over whole surface S is also defined as electric flux linked with the surface. I repeat, surface integral of electric field over whole surface S is also defined as electric flux linked with the surface. Now look at the diagram. This is surface S, this is small surface ds, this is the area vector of ds, and this is electric field vector. S vector are inclined at an angle theta. Okay. So how mathematically we write this expression of electric flux? So phi E is equal to integral E dot ds, and when we integrate over surface S, then phi E would be equal to E dot S. Okay, this is how we alternately define electric flux in terms of integration. And now assignment 1.5 continued. Question number 5. In the following diagram, state whether electric flux linked with surfaces S1 and S2 is positive or negative. Calculate electric flux linked with the surfaces S3 and S4. Also, calculate electric flux linked with surfaces S3 and S4. S3 and S4 also. Question number 6. A closed cylinder is immersed into a uniform electric field as shown. Calculate electric flux linked with the cylinder. Now question number 7. Calculate electric flux linked with a sphere of radius r which encloses a charge q located at its center. Question number 8. Consider a uniform electric field E equal to 3 into 10 raised to the power 3 I Newton per Coulomb. I means it is directed along positive x-axis. I is unit vector, which shows that the field is directed along unit vector. A part. What is electric flux of this field through a square of 10 centimeter on a side whose plane is parallel to YZ plane? B. What is the flux through the same square if the normal to its plane makes a 60-degree angle with the x-axis? C. What is the net flux through a cube of side 20 centimeter oriented so that its faces are parallel to coordinate planes? Here are the answer for A, answer for B, answer for C. So you solve these questions on the basis of the text that you have learned and compare with the answers that you are able to solve these questions. Thank you so much. God bless you. Tomorrow we'll continue further with this topic. Thank you once again.